When building this table, you can use any type of wood or material that you desire. We chose to use a natural solid surface material from Phoenix Biocomposites called Environ. You can glue it, mill it, and finish it like wood. Plus, unlike other solid surface materials, it can also be glued directly to the wood. This new material is roughly twice as strong as wood and comes in several different colors. It could really open up some new possibilities for your work. Here are just a couple of samples that we played around with. To start this project, we cut the 1-inch thick material to size and glued up the legs. We then used a bandsaw to cut the outside surface of the legs. After cutting one side, we taped it back to the stock and cut the second side. This process saved us a lot of material and time. We then used calipers to mark the centers at exactly 1 inch from the inside surfaces at both ends of the workpiece. Next, we drilled a single hole on the bottom end for the indexing hub and a hole at the top end for the live center. This material is so dense that it requires a pilot hole whenever you're using screws. Mount an index hub with a single screw in the center on the bottom end of all 4 legs. Make sure that the pilot hole is large enough to avoid breaking the screw head off. We used the 40 position index plate to keep the milled flats as small as possible. Now insert the leg into the system and then bring the bit down onto the surface. Now rotate the leg until the top surface of the workpiece is level with the top rails. Then mark the position of the index hubs. This step will ensure that you remove as little material as possible when milling the ends square. Carefully remove the leg from the machine and use a center punch to start the holes for at least one more screw. Environ is hard enough that it only requires one extra screw in the corner. Softer woods may require more screws to secure the index hubs. Be sure to tighten both screws. Now reinsert the stock into the system. Next, lay out the templates and then cut them with a bandsaw or jigsaw and sand them smooth. Remember, any bump or rough surface in the template will also show up on your part. Use the first template to mark the profile onto the flat surface of the stock. Then index the leg 90 degrees and mark the inside profile with the second template. Mount the baseboard for the templates as shown in the assembly video. We built this baseboard with the support underneath to give it strength, and a series of holes 6 inches apart to mount the templates to. Be sure that there is clearance for the carrier tray, and then secure the baseboard in place with the wing nut. Now bring the bit up to the line at one end of the stock, and then position the template. As shown here, we used Magnate's 1/2 inch spiral down cutting router bit for this operation. Now position the template and clamp it in place at both ends. Drill through the holes in the baseboard to mark the hole position in the template. And then finish drilling the holes. We used all of the holes to ensure that the template would not flex when milling the leg. We used cap screws and a wing nut to fasten the template to the base. You could use any type of screw that you might have handy. Just make sure that the router base clears the head of the screws. Position the router at one end of the curved profile and place a clamp on the top rail as a stop at each end, and then mill from the tailstock toward the headstock. Because the profile has already been cut fairly close to the line with the bandsaw, we plunged the bit at full depth and made 2 passes to remove the rest of the stock. The final pass should be made in the opposite direction, or from the headstock to the tailstock. When milling in this direction, the bit is climb milling to give the best possible finish. When you have completed milling the first surface, rotate the indexing head one position and secure it with the indexing pin. Mill each surface from the tailstock to the headstock and then return to the tailstock to clean up each pass. We use the dust collection system while milling these components to keep the dust out of the air and contain the mess for easy cleanup. Repeat this process 10 times to complete the 90-degree arc on the outside surface of the leg. When you have finished this process on the first leg, remove it from the machine, and then repeat the process on the other 3 legs before moving on to the next step. For the next step, we used Magnate's surface cleaning bit number 2704 to mill the flat surfaces on the top of each leg. Clamps were set to limit the travel of the router when milling the flat surfaces on the 2 outside surfaces. Set the plunge depth to remove as little material as possible, and then bring the router bit approximately 3/8 of an inch into the material and mill from one stop to the next. Then bring the router in another 3/8 of an inch and make the next pass. Repeat this process until you have completed the flat. Now index the stock 90 degrees to mill the other outside surface. And repeat this process for this side. For the inside 2 surfaces, we move the bottom clamp approximately 1 inch. Now lay out the slotted dovetails on one of the inside surfaces. For the dovetails, we'll start by milling a relief cut with a 2-flute straight cutter. Then we'll finish cutting the slot with a 3/4 inch wide 7-degree dovetail bit. Position the router bit for the dovetail slot and set the router stops on the carrier tray. Then position clamps on the top rails to limit the length of the slot. Plunge the 2-flute straight cutter down to rest on the surface of the material, and then set the plunge depth for exactly 1/2 of an inch. This relief cut should be made in at least 2 passes to ensure that the cut is perfectly straight. Now index the leg to the other inside surface and mill the second slot. It is important that you repeat this process on all 4 legs before changing bits to mill the dovetail joint. Now using the dovetail bit, set the plunge depth for 1/2 an inch. When milling a dovetail slot, the bit must be plunged to the full depth and the slot milled in just 1 pass. The relief slot will keep the sawdust from loading up the bit. Again, repeat this process on both inside surfaces of all 4 legs before making the next setup. The keyhole is made at the top of the slot so that it will be removed when we cut the leg to length. Now place the second template on the baseboard and line up the spiral cutter with the line marked on the leg, the same as before. Again, clamp both ends to temporarily hold the template in place. Check that the bit follows the line before drilling the holes in the template. Again, drill from the bottom of the baseboard to mark the template. and then finish drilling the holes through the template. Mount it to the baseboard with machine screws or cap screws, the same as before. And once again, be sure that the heads of the screws are set low enough to clear the router base. The leg should now be inserted with the curved profile up to start milling the inside profile. On this side, we did not cut the material on the bandsaw first. Therefore, we needed to plunge the bit approximately 1/2 of an inch per pass to mill the first side. If the leg is cut roughly to shape on the bandsaw first, you will speed up the milling process and not make as much sawdust. Again, begin each pass from the tailstock toward the headstock and then make the final pass in the opposite direction. When the first surface is complete, index the stock one position and repeat the same process through 90 degrees, just like we did on the outside profile. When the parts are finished, you will have small flats on the large diameter sections that you can easily sand to a very smooth surface. The next step is to cut the legs to length. You can cut the rails to the pattern supplied with the drawings or create your own designs. After you have finished cutting the profile and sanding it smooth, you can then route the edges. We chose to route only the outside of each rail and leave the inside straight. Use a router bit with a bearing guide on the bottom and mill the bottom edge of each rail. Then use the same 3/4 inch 7-degree dovetail bit to mill the dovetail pins on the ends of each rail. Cut the pins a little oversized to begin with, and then make fine adjustments until the joint is snug. This type of joint requires no nails or screws, and once glued together, it may never come apart. All that's left is to complete the table with the finish of your choice. Then start enjoying this quality piece of fine furniture that will last a lifetime.